everybody, I'm Elisa and I'm back. So we are continuing on with the circulatory system. We're looking at blood, and this time we're going to explore the life cycle and the development of the white blood cell. So leuko, as we've been talking about in the leukocyte, is referring to the idea of it being lucid. So when they were first seeing these types of cells under the microscope for the very first time, compared to red blood cells, which were pretty red, they were like kind of see-through. So leukocyte, but now we know there are different types of leukocytes. We're going to look at what those are, but they do kind of have a general life history and purpose that's relatively similar. So let's look at how they are born into this world. So that would be the process of what we call leukopoiesis. So remember, like leukos referring to like that lucid, that white blood cell, and then poiesis, think like stem cells, right? So they're two L's. So just like all the rest of the parts of the blood, white blood cells are made in the bone marrow, right? And so these hematopoietic is what I want to like kind of divide the hemato, right? So heme group. So hematopoietic is going to be referring to like blood cells, right? Anytime you see that. Poietic is referring to the fact that they're, again, poiesis, they're stem cells. And what these are going to do, these hematopoietic stem cells, HSCs, which I will try not to use too many abbreviations, differentiate into distinct colony forming units, which we already talked about. And so what it means is you have, one stem cell and they divide into multiple eventual cells. And everybody who's born from that is like the colony that they're referring to, right? So the thing about these colony cells is they can do a lot of stuff. So they are what we call pluripotent, meaning there's many different cell types they can commit to, right, or turn into. Not all of them, right? You're not going to get any toe cells, you're not going to get any hair cells, but you're going to get some blood cells. In this particular instance, we're going to get white blood cells. So one of the progenitor or like the original cell lines that we'll look at are the myeloblasts, right? And so these are going to form the neutrophils, the eosinophils, and then the very similar basophils, right? Monoblasts are a little bit different. So they're going to go on and form that big, large cell, the monocyte, very large, traveling around, eating up other damaged cells, rogue cells, and maybe virally infected cells. Those that need to, they're the cleanup crew, but they're very large. And so they really have that one monoblast origin, right? So, as opposed to like myoblast 3. So the other thing is the lymphoblasts. So this is different. So all forms of the lymphocytes will look primarily at the B cells and the T cells in this class, okay? So the neat thing about the B cell and the T cells is they get educated. They're educated cells, you guys, just like you out there. They actually get educated, not only how to fight specifically, but how to adapt and recognize new foes, right? So that's like just this very cool thing about them. But all right. We'll also look at T lymphocytes a little more closely. They go to college out in thymus, right? So they left town to go to finish up. So it's kind of a cute thing about those, and we'll get into this a little more. So when we're talking about the marrow, I just want to kind of reiterate that we're always talking about the red marrow. The red marrow. And the red marrow is always storing and releasing these granulocytes, right? So things like especially eosinophils and basophils and the monocytes right here, those big puppies. The leukocyte life cycle. Circulating white blood cells do not stay in the bloodstream. They have to travel outside of the bloodstream to go into the tissues and organs. Granulocytes, they leave in about 8 hours and they can live 5 days longer, right? So that's why sometimes if you get, especially granulocytes are really implicated in like itchy stuff and swelling stuff. So if you have like an itch or like a spider bite, like a bug bite, hopefully not, we're in New Mexico, it's pretty bad spiders out here, but Even like some dermatitis, you're out camping, you scratch up against something that makes you kind of itchy, it's going to last for a few days unless you can get that off of you. So just, something to be thinking about. Maybe not 5 days, but the irritation can, because they are going to constantly be kind of releasing in that area. Same thing with lots of things like cuts and bruises, or well, mainly cuts like lacerations, all that. Monocytes leave within about 20 hours and they transform into, remember those big cells, the macrophages, big macro, and phage is eating stuff, big eaters. And they can live for quite a while. Apparently, they can live for about several years. Lymphocytes provide long-term immunity. So these are the ones that we're talking about that they go to school, right? They're the educated cells. They are soup school. Um, and sometimes not so long term, but they can, like they definitely can. So those of you who have had like vaccines, right? So you'll know you'll get a vaccine or a couple sets of it, and then you're supposed to be good for life or good for a while. That's largely in probably exclusively due to the fact that these lymphocytes get educated by that vaccine. And after they study the vaccine, they can go out and actually get those like invaders pretty readily, right? And they'll recognize them. Oh no, I got recognized. So they're continuously recycled from the blood into the tissue, into the lymph, and back into the blood. And they can teach other ones, and they give rise to new cells. And there are some that are very old that like hold the knowledge for those years. So we'll look at all that. Um, so colony forming units, right? Colony forming units, we keep seeing that. And so what it is we have that stem cell, and this is pluripotent. I mean, it can go into any of these different cell types. But the colony forming units are important because this is like a real dedicated step, right? So this is when we have dedicated after after our first division from the stem cell, the stem cells had some divisions, and these are the baby cells that are coming from it. And these baby cells commit, and they commit to either being eosinophils, or they commit to being basophils, or neutrophils, or monocytes, or lymphat. So like all of those different cell types, right? So these are the next stages. So once a cell, is divided from, mama cell down here or daddy cell, and says, okay, I'm going to go out into the world and I'm going to be an eosinophil. I'm going to do it. They have to do some things before they become an eosinophil. They have to develop, change, mature, and then they can become like a full-fledged eosinophil. So they have to learn the skills. They have to grow the parts. They have to fill up those granules with all kinds of things like histamine. And so that's what we mean precursor cells. So precursor cells are like they're developing, right? They're not quite finished. Oh my gosh, my handwriting. I'm just going to scratch that and just try to print it. Finished. There, right? So they're not quite there yet. And so we have a lot of folks that I notice ask questions about like, well, what does that mean? Why don't they just, a lot of people I think that there's just other eosinophils or basophils or mature cell types floating around in the blood all the time, and they divide there. And that's not the case. This is in the marrow. Please remember, the red marrow, think red for blood. And it's important because it allows these stem cells to, be adaptive to the needs of the body, and also store information, and then also have like this like smaller isolated population and colony. So once these guys are out in the blood, floating around, going through the tissues, they're going to encounter lots of things like toxins and, radicals, right? Like things that are going to damage them in some way or another. And we don't want damaged cells producing more damaged cells. That's how we end up in cancerous states. So it really is important that we do have this protected hemopoietic stem cell that's like cuddled down in the bone marrow, all safe and tidy. Okay. So some of the leukocyte disorders that we look at have to do with how many leukocytes are we seeing. Anytime you see penia, think low, not enough, right? So a low white blood cell count means that we're like going to take this little microliter of blood. And I mean, a microliter is so tiny, like a tear, a big boo boo crying your eyes out tear because you watched, like a super sad movie. That's like 30 to 50 milliliters or microliters about. And so that teeny tiny drop has got to have around over 5,000 white blood cells, right? Some of the things that cause low white blood cell radiation poisons, infectious diseases, specifically viruses like, HIV, which can target specific white blood cells. And one of the problems is when you have no defenders, you are left vulnerable. And so oftentimes we'll know that someone might be experiencing leukopenia because they are like always sick all the time, right? Or they have repeated infections or they can't clear an infection. And so that's one of the reasons we would go in and we'd start looking actually at the blood itself. Okay, leukocytosis is different. So cytosis means there's a higher white blood count. And so this is when we have like 10,000 or more. And so people actually do enter into phases that are very similar to like, or maybe even in, when you're really fighting like a leukocytotic level. And so if you have infections, you've got a really bad strep infection. Sometimes you are experiencing some serious allergies, other types of disease, including those are when we need lots of white blood cells. And so that high count is, well uh, derived, I guess, right? So what that means is we start looking at like which ones is it? So like, we got a lot of eosinophils or maybe we got a lot of basophils or, who is it that the body is calling on? And so we can take a look at what we call a differential. So we can see the difference between what types of white blood cells, right? And that can give us a little bit better idea of what's going on. And that also lets us look for cancers, right? Because if we find that we are not fighting an infection, we don't have allergies, there's not some other causative agents that we might be looking um, possibly in the like a leukemia type setting. Okay, so that's it for this video. I'm going to keep talking about white blood cells, lifestyle, life cycle, lifestyle. Yeah, actually a little bit of that too in some of the next videos, but I think that's pretty good for now. And I hope you're having a wonderful day.